I want to present to you some of the progress that we are doing now with the TVB, what before was called TVB HPC, and now it has mostly evolved into two things. So one is a domain-specific language for the definition of models in TVB, which is capable of producing both CUDA code and Python code automatically from a higher level definition. And also, how are we supporting the current SGA3 workflows, especially the ones from Work Package 1, with this solution? And I first wanted to show you this environment where TVB is being related to the different parts of EBRAINS, the different simulators. And of course, this is not a comprehensive list of things, but just a small sample of things that can be connected between themselves. And what we are hoping for is to be able to leverage the best parts of each of the different tools in EBRAINS, right? With TVB and with the simulations and strategies that we have. So, of course, at this point, we are mostly working on the part that for Work Package 1 is relating the experimental data to the modeling, and sorry for the to the parameter explorations. So, in order to support this kind of workflows, which integrates data into the model and then hope to do fitting efficiently on the infrastructure, our approach is to use RATEML, so the main specific language of TVB, to actually integrate the different data features into the model. So what you see here is the generic workflow that we are using from the already exported data sets from the Atlas, let's say, which can be already accessed by the knowledge graph. So this is, let's say, a step taking the output from what Timo is doing, and together with the different hotspots in Work Package 1, especially with the work that Gorg is doing, we are now defining a generic translation module, which will be able to implement the combinations or functions on top of a specific microscopic data features and translate them into macroscopic data features. This combination, of course, this has to be a sum. This can be any combination of these microscale data features that are being mapped to these macroscale data features. After this translation module has processed this data set and produced the required data features, these can be linked through the domain-specific language to parameters that are included and used within the dynamics of the model itself. So here you are free to define your model or to use as a base the models that are already present in TVB and extend them or substitute or add the different features that you are interested here. Once you have produced your description at this level, which is a very high level, normal, human readable level, then you can use the DSL framework that we have developed during SGA2, and this is still in development during SGA3, to do a first model validation and then an automatic code generation to a specific target. This means that you can either produce Python code with this, or you can produce, at the moment, also CUDA code for doing parameter sweeps on GPUs, or for doing simulations, single simulations with Python. One interesting thing here is you can also specify, of course, the parameters that you would like to explore, which can be swept during the parameter sweep. So these are parameters in the model that are that can be changed by the user and can be varied by a parameter sweep. So your model then becomes a specific, let's say, instance of this model for your use case. And well, for the moment, we are implementing the translation module, which is very simple from us. So there's no, this is a very generic thing that we are only hoping to have a clear interface for what is coming in as potential data from the knowledge graph and what we need to output so that the DSL can interact with it when the user is defining these links between parameters. We have a proof of concept working where you can already collect some data, fake data for the moment from the knowledge graph. But this is, of course, also a very simple component that just grabs the data and lets you then do the mapping based on this translation. And we are in the earliest stages of this proof of concept to link everything to the automatic code generation, but this is it's progressing quickly. So we hope that in the next months we're going to have something available already from the Collab 2 that is able to do a sample, go from data to model to translation to model definition, model code production and simulation on the IC resources. At this point, we have a simple example in the Collab 2 using a connection to Yusuf to do only the steps of uploading model, translation, automated code generation, and sweeps. And have good news, the CUDA sweeps will be merged hopefully very soon to TVB root. So we are working hard to prepare the pull request, and then we hopefully will have this code available for everybody directly, and also available in a more practical way for testing in the collabs. Because for the moment, because this is not still in the TVB root, we have to link our installation to our repository. And in parallel to this, to all these things, within the TVB cloud context, so the partner project from the HPP, we are working on a graphic user interface for this domain-specific language that is an extension of the TVB GUI. So we hope to develop a concept. This is very early still, but we're gonna develop a concept that we will, of course, discuss with the TVB development teams, hoping to have something like a new tab in the GUI where you can have the user define their new model, add the description, have the target output, and then create the model, and even do some initial validation of the model characteristics, and then produce the code and go to the parameter sweeps. Well, thank you very much for I don't have too much time to go deeply into the different things, but this is a joint effort of, I think, the whole HPP, because we interact with everybody from architecture to scientists to work definition, and I think this is of course the only way to make this work, because it's just so many components. But I am hopeful that this is going to be working very soon. And of course, thank you, Petra, for organizing these workshops where we can discuss these things, and to the different development teams who constantly discuss and try to refine these concepts. And so I think I'm already over my time. I had a quick example of this collab 2 collaboratory that we're doing, but it is not so fancy visible. But what we can do is just connect to Yusuf, which is the IC supercomputer located in the JSC in Jülich. We let the user upload their model definition, where you can say, okay, I want to explore these 2 parameters, and then you define how these parameters are integrated into the model. You can transfer this model to HPC, and then define your job, in which the code is automatically generated in the HPC resources. It is executed for a certain combination. So, for example, here you are doing 120 different values of the first parameter, and then 120 values of the second parameter. So that's about 14,000 parameter exploration on a single GPU for this model, and then you can run this job, wait until it's finished, and you can collect the results afterwards, just as a normal job using Unicore. We hope that this becomes better available to everybody very soon, and that we can work together with the development team also for integration of the GUI in a few months. So thank you very much.